Moving on to part two of our conversation, I want to talk about a few common forms of misuse of self-retracting devices that have kind of stimulated the standards writing activity. The first phenomenon of misuse that I would like to discuss is foot level tie-off and insufficient clearance. Now, this behavior has been endorsed, if not encouraged, by earlier versions of the standard and by manufacturer narratives. And when we introduced leading edge self-retracting devices, originally back with the 2012 edition of this standard, the idea was to create additional protective measures for the use of these devices in below the dorsal D-ring tie-off applications, up to including those which might result in contact of the device line with the structural edge that the user was falling off of. And the testing that was developed to qualify products under that standard simulated conditions most similar to those in steel erection. But again, as we talked about briefly, variables change outcomes. And if we try and account for all of the variables that exist in the workplace and with all of the imaginable substrates, it becomes quite a challenge to determine whether or not we can create a system that is 100% protective in all of these circumstances. So when we choose to tie off at the foot level, we introduce a couple of different problems. One is that we have these substrate variables that are difficult to predict. And we also have to question whether or not we're going to have sufficient clearance to safely arrest the fall. So in the example shown in this video, we can see that there is an obstruction in the fall path. And based upon what happens to the dummy at the conclusion of that fall, we can see that this is likely to result in several potentially serious mechanical injuries. And despite the fact what we have here is a quote unquote successful fall arrest, the dummy didn't hit the ground, we still came in contact with the substrate on the way down and the obstruction that was in our fall path. And we have a user here that has probably been significantly injured and is not going to be returning back to work anytime soon. And in fact, there's always a potential that the injuries that this person saw could potentially be life-changing. So when we look at the use of these devices, we're trying to inform users how to use these devices to maximum effect. And when we tie off below the level of the dorsal D-ring or to the surface that we're standing on, we're not using the self-retracting device to maximum effect. Misuse number two will be illustrated in the next slide. But what I want to show here is what was a self-retracting lanyard always meant to do. And in this particular video here, we're going to see something that's not terribly exciting. And that's it. There's nothing to it. When we tie off to an anchorage that is overhead and proximate to the working location that we're engaged in our work at height activities in, it's a non-event. There's very little that happens because we have a rapid locking engagement, we have a very short deceleration distance, and we have a very predictable outcome. So the elevated anchorage gives us the best performance possible and allows that device to perform to maximum effect, and that should always be our goal. Related to that, the misuse factor of swing fall is something we need to consider, and this has to do with a lack of proximity to our working location. And in this particular circumstance, we're going to see a test dummy subjected to a swing fall. We can see over on the left-hand side of the screen or the video, the dummy is suspended at that point, and the self-retracting device is about 20 feet over to the dummy's left-hand side. And when the dummy is released, we see what the result of that circumstance is. And it's a rather violent collision with the column, which is directly in that falling user's swing path. So that element of proximity is really important when we're using self-retracting devices or any fall arrest connecting device. We want to be as close to and directly beneath our anchorage as possible to get the most ideal circumstances and the most predictable outcome. Misuse number three would be the use of personal self-retracting devices in aerial lifts. And I kind of pose the rhetorical question here at this point. Between these two choices, which do you feel is the safest choice? Many in the consumer market believe that the personal self-retracting device is in fact safer than an energy-absorbing lanyard. And I would tell you that that's not necessarily the case. Most personal self-retracting devices that are being used in these applications are exactly like the one pictured here. And this is what we'll discuss a little bit later on in this presentation as a class 1 device that is intended for use on overhead anchorages. And most of those are going to have an energy absorber that is adjacent to the anchorage and connector. So when a user wears this device and ties off to the anchor point inside of the aerial lift basket, that energy absorber stays in the basket when they fall out of the basket and go over the top rail. It is therefore isolated and it's inhibited and prevented from deploying. So when compared to this type of device, the energy absorbing lanyard is much safer because the shock absorber is attached to the dorsal D-ring and follows the user out of the basket and remains in line with the force vector. So it's important that we take a look at the capabilities and limitations of the devices that we're choosing for the application that we're working in, and consult those manufacturers' instructions to determine which is going to be the best fit for us. In many circumstances, we're making the wrong choice based on a misunderstanding. So my best guidance on this would be to avoid kitted products and really look for products and choose from a menu that is going to fit your specific application related needs.